Hello students, how are you? Welcome to another video number 12. Today we will be making automatic obstacle avoiding car. This car will be based on ultrasonic sensor. So let's get started and try to make a car out of our Arduino, a chassis, a couple of motors and motor module in order to make our Bluetooth car. This is the working of a car. As you can see, it's automatically reversing and turning in order to avoid the obstacle. As you can see, our motor shield stacks on top of the Arduino Uno board itself, so there is no need of any other connection in it. Next, moving forward, we need to connect our battery pack, that is the 6-volt battery pack made out of 4 cells that's provided in the kit, to the positive terminal and the ground terminal. Next, we need to connect the left motor and the right motor as shown in the diagram. Currently we do not need to connect the ultrasonic sensor because of the fact we are currently just testing the Arduino motor module and the motors, and we are not getting any input from the ultrasonic sensor. So as you upload the code, our car will start moving. Make sure that there is a jumper wire, that is the power jumper. It is connected if you are using the same 6-volt power supply in order to power your Arduino also, but make sure it's disconnected when we are trying to supply different voltages, that is either from the USB port on the Arduino or power DC jack onto the Arduino. Make sure it's disconnected if we are supplying two different voltages, motor shield and the Arduino board. Let's get started with the code and try to understand how does this car work. So initially, as we can see, we have here included the library that is AF motor, and then we have declared two motors, that is the left motor and the right motor, at pin number 4 and motor number 3. Then we move ahead to the void setup part where we declare the serial port, that is 115200, and then we print Weissing's car. Next, because of the fact that this is a test code, we need to test all our connections and our motor. We are using this code. Next, we move ahead to the void loop part where we declare the left motor and right motor to run forward, and then we set the speed to 254. The speed varies between 0 and 255. So now we have set the speed to 254, and then we wait 500 seconds. That means the motor will run forward for 500 milliseconds, and then we turn off the motor by the command that is left motor dot run release and right motor dot run release for a 1 second delay. We wait for that 1 second, then we start moving backward. Similarly, backward also, we have now declared the left motor run and right motor run to be backward with the same speed set. The delay is 500 milliseconds, and then we release. What we need to do if you want to turn left or right, now think of it in this way. If we turn the left wheel forward and the right wheel backward, we will be turning rightwards, and vice versa. When we turn the right wheel forward and the left wheel backwards, we'll be turning towards the left. So as you can see, in order to turn left, we have again done that. We have made the left motor run backward and the right motor run forward, and that way we could turn the bot left. And similarly, we have turned the car to the right by turning the left motor in the forward position and the right motor in the backward position. Then delay is 500 milliseconds, and then we stop the motor, and this whole loop is repeated. So now let's move ahead and see what we need to do if we need to connect our ultrasonic sensor also. So let's move on to the wiring diagram first. Here, as you can see, we have connected all the rest of the things in the similar way as we have connected previously. However, we have additionally added an ultrasonic sensor onto the shield itself. Now connecting the 5-volt pin to the VCC pin, trigger pin to the pin number 4, echo pin to the pin number 3, and ground pin to the ground. That's how we can simply connect our ultrasonic sensor also. Now let's go ahead and understand the code and how it works. So here in the code, as you can see, this is the code for the ultrasonic sensing automated car that will automatically detect obstacle in front of it and then turn left in order to avoid them. As you can see in the line number 1, we have included the AF motor library, and we have declared the pins for the trigger and the echo pin, that is pin number 4 and 3. Then we have declared two long variables, that is duration and centimeter. We move forward declaring the left motor and the right motor, pin number 4 and 3. Next, we begin the setup where we begin the serial port and print Weissing's ultrasonic car, and then we declare the pin mode, trigger pin to be output and the echo pin to be input. That means there will be a trigger pulse that will be sent by our ultrasonic sensor and will be waiting to receive that pulse on the echo pin, what we do is we send a trigger pin low and a high after a delay of 5 microseconds and after 10 microseconds again. So we measure that pulse and the duration it took to receive the pulse back and calculate the distance in centimeters by multiplying it a calibration factor of 0.0160. Now we print the centimeter distance serially. Now say if the centimeter distance is more than 20 centimeter, that means there is no obstacle ahead of it. That means the motor, that is the left motor and the right motor, are set to run forward at a speed of 254. Else, that means if there is some kind of obstacle within less than 20 centimeter in front of the car, turn off the left and the right motor for a second and let the car sense the obstacle in front of it. We set both the motors to run backward at a speed of 254. We wait for 500 milliseconds when the car is reversing. Now, in order to turn left, we use this. That left motor turns backward and the right motor turns forward for 500 milliseconds. That means in this duration, the car is moving towards the left. After a delay of 500 milliseconds, we again turn power to both the motors, that is in the line number 51 and 52, that is motor dot release, and this loops continues forward ahead and ahead in order to make sure that car is avoiding all the obstacles and it running smoothly when there is no obstacle ahead of it. So students, this was it for the video number 12. Hope to meet you next time. The next video will be our last video in this video series, so stay tuned. We'll meet you next time. Thank you.